Hi, my name is Jackson, and my plan is using AI in natural disaster recovery. So my plan is using a robot powered by AI to traverse a dangerous environment to get information about the environment and send that to first responders so that when they enter, they'll know where dangers are and they can operate in a safer environment. So my idea of achieving this is using machine learning, which has data which is sent to a rule set, which based on that rule set, we decide an output. So machine learning has many parts to it, but the part I want to use is reinforcement learning. Now reinforcement learning has 5 parts to it: the agent, environment, state, actions, and reward. The agent is the model we are trying to train. The environment is where the agent is exploring. The state is each time step of the environment. The action is how the agent interacts with the environment, and the reward is what it's trying to maximize. So say for our time step, we request a decision, which then the agent collects observations and then uses that optimal policy to decide an action, and we return that value as a float of probability. And based off that float, we decide what move the agent should use or what action it should use. So my research problem is that creating 3D scenes that are realistic is difficult, and training reinforcement learning models without any help is also difficult. So my solution is to use Unity. Unity is a game engine built and it allows for 3D rendering of scenes in real time, and it's relatively easy. It also has a built-in physics engine, and it also allows for a package called ML Agent, which is used to help speed up the process of machine learning. So using Unity, you can create a 3D scene relatively easily using their 3D tools. This is the environment the agent will learn to explore, and will learn to explore the most of this environment without hitting any walls or fires. Right now, I'm controlling the agent with my WASD using heuristic control, but I'll show the AI later on in the video. These are the scripts used to control the agent in a 3D environment and interact with Unity's scene. And we use this using the agent class and the model behavior class. So these are the network parameters used to engineer how the neural network will look like for reinforcement learning training. So on the left side, we can see this handles more of the training process and the hidden layers of the neural network. And we see this in the top where it asks the training type and we put TPO, which is the algorithm which we're going to use. On the right side, this more designs the Unity aspect of it and also the output and input layers of it. So these are the first results from my first training. So qualitatively, we can look at them and see how the agent does somewhat work. However, we can see that it goes sometimes towards danger, as you can see in the bottom picture, as it's literally driving right towards the fire. But in the first picture, we can see that it did somewhat avoid a wall. Now, if you look at this through graphs, we can see that the cumulative reward is higher, which is good, but the episode length becomes really short towards the end of the training. So this means that we don't have an incentive for the agent to keep itself alive within the training. So my solution is using a linear reward model for rewarding the AI after the training based on how long it lasted. And we can mathematically write this out as RT is equal to BT. Simple as that. T is simply how long the episode has lasted for, like how many time steps. So say the episode lasted 20,000 time steps, then our reward would be 20,000 multiplied by some base or B. Now the challenge is we have to find the value of B. So to find B, I use 3 trials using different bases. For the first trial, I use the base of 0.002. For the second trial, I use the base of 0.02 and use a different punishment algorithm. And for the third trial, I scrapped the new punishment algorithm and used the base of 0.05. The first trial was most successful as it balanced survival and exploration the most compared to the others. So our first trial, our agent still retains the ability to avoid fires and also avoids walls. It also lasts way longer compared to before, as with the blue reward trails. This means that our implementation of a linear reward system for survival is working. However, one flaw of it is that it seems to only explore within a radius and doesn't explore much outside of it. So in conclusion, the creation of a reinforcement learning model to traverse a dangerous environment is possible. The agent in our first result did somewhat work, however, could have been improved. One problem is that it did not have an incentive to live, so we did this by creating a linear reward model based on how long the episode lasted. And through trial and error, we found that 0.002 was the best base based on our knowledge.